So in this video we're looking at factorizing quadratic functions. And when we talk about factorizing, it's about taking out a common factor and writing it in a simpler form, or in a different form, really, not a simpler form, but in a different form. So you're looking at taking out a common factor and writing the function in a different form. So let's look at this quick example up here. We've got x squared plus 4x, and we need to find a common factor between both these terms. Well, the common factor between both these terms is x, because this x squared has an x, and this 4x also has an x. So we can take x out as a common factor. And what are we left with? Well, if we take 1x out of x squared, we're left with an x. And if we take the x out of the positive 4x, we're left with positive 4. And that is how we factorize a quadratic function. But all quadratic functions do not look like this. And we'll go through another example to see what other quadratic functions look like and how do we factorize for those quadratic functions. So let's look at another example. Again, we'll go over here and we've got x squared plus 3x plus 2. And we're looking at factorizing this function right here. So again, we're looking to find a common factor. Well, we can find the common factor over here. There's an x over there and x over there, but there is no x over there. So we can't really factorize this. Well, there is a little trick you can use. Right? So what you're trying to look at is you're looking at two numbers that multiply to equal 2, but those same two numbers add up to equal 3. Well, let's look at all the numbers that multiply, or factors of 2. So factors of 2, well, we've got 2 times 1, or 1 times 2. Cool. These are the factors of 2, right? And well, we know 2 times 1 equals 2, and 1 times 2 also equals 2. And if we, well, let's go 2 plus 1, well, that equals 3. And 1 plus 2 also equals 3. So both of these work for our particular function. And what we could do is we can rewrite our function like this. X squared plus 2x plus x plus 2. So we change that middle term, split it up into two different parts, factors of 2. We split it up. And what we can do is we can factorize this separately. So we can factorize this side first and factorize this side next. So let's factorize it. Well, obviously a common factor between these two terms right here is x. So we can take x out as a common factor. Now what are we left with? Well, we're left with 1x from here, and we're left with positive 2 over there. Well, let's think about a common factor over here. Well, there is no common factor, but there is a common factor of 1. Alright? What we can do is we can take 1 out as a common factor. Alright? And what are we left with? We're left with x plus 2. So if you think about it, if you multiply the x back in here, you get x squared plus 2x. And if you multiply the 1 back in there, you get 1 or x plus 2. Now what we could do is now we look at this whole function as a whole and see if we could find a common factor between this term there and this term there. Remember, this is one term now, and this is our second term. Well, the common factor should be pretty obvious. Our common factor is right there. X plus 2 is a common factor between both of these. So what we could do is we can take x plus 2 out as a common factor. And what are we left with? Well, we're left with x plus 1. And we have factorized this term to make it look like that. Well, we have changed this term to make it look like that by factorizing. Alright, so obviously if you expand this out using the FOIL way of expanding, you should get that same term or that same expression right there. Alright, so let's look at one more example. Okay, a similar example. So let's look at x squared minus 4x plus 3. Alright, so again we're looking at two numbers, or the factors of 3 that multiply to equal 3 but add up to equal negative 4. Well, we've got 3 times 1, which equals 3, Right? But positive 3 plus 1 equals positive 4. We want negative 4. Wow! We know that negative 3 times negative 1 equals 3. Negative times a negative equals a positive number. And negative 3 plus negative 1 is equal to negative 4. Negative 3 plus or minus becomes a negative, so minus 1 becomes negative 4. So now, I'll just go up slightly so I've got a bit more space. We can split it up. We've got x squared minus 3x minus x plus 3. And again, we can treat it as two different terms. So if we take out a common factor over here between these two, we get x as a common factor, and we're left with x minus 3. And over here, we can just take a negative 1 out as a common factor. Oops, sorry. And we're left with x minus 3. Alright, if we multiply this back in, we get negative x, and negative 1 times negative 3 becomes positive 3. And again, we can see it. There is a common factor of x minus 3 between both terms. So you get x minus, oops, sorry. Just get rid of that real quickly. X minus 3 and x minus 1 as your factorized expression. Well, now let's look at a different example with a value, or the first term value greater than 1. We've always looked at just x squared, or 1x squared. Let's look at 1 greater than 1. So let's look at this one over here. So we've got 2x squared plus x minus 3. Right, I'll rewrite my 2 so it looks a bit more neater. Now with this one, you have to do it slightly differently. Alright, and I'll show you what you will do. You'll use the exact same method, but that first step will be slightly different. So the first thing you have to do is you have to take these two numbers over here, this number there, 2, and you have to multiply it with a negative 3. So you get 2 times negative 3. And that equals negative 6. Now you're looking at two numbers, alright, that multiply to equal negative 6, but add up to equal positive 1. Alright, and obviously we know that 2 times 3 is equal to negative 6. So if we went 2 plus minus 3, well, that equals negative 1. But we're looking for positive 1. So we can just switch it around, and we'll go, well, negative 2 plus 3 equals positive 1. And now we can split that middle term up again. So we get 2x squared minus 2x plus 3x minus 3. Alright, so we've split that middle term up. Alright, obviously minus 2x and plus 3x equals just x. And now we can split this into 2 again, as we normally have, and factorize it. So a common factor between these two is 2x. So we can take 2x out as a common factor, and we're left with just x minus 2. Oh, sorry, not x minus 2, my bad. X minus 1. Sorry, remember we've taken 2x out as a common factor. Now over here, we can take 3 out as a common factor. Alright, so we take positive 3 out of the common factor and we're just left with x minus 1. And now we look at this quadratic function again and go, well, actually, there's another common factor over here. We've got x minus 1 and x minus 1 in brackets. So we can take x minus 1 as a common factor out. And what are we left with? We're left with 2x plus 3. So obviously, the only different step with a value over there greater than 1, so it could apply to a value of 2, 3, 4, 5, anything over there, that first term, anything attached with the x squared greater than 1, you just need to multiply that number there with the last number there, and then determine that value, and then make sure you find factors that equal that number there and also add up to be the value in front of just the singular x. And that's how you go on to factorize quadratic functions.